I'm going to try to talk as much in the session, right? And try to cover a lot of work in terms of what we're going to do for the rest of the term, okay? And basically for the whole term, okay? So I'm going to speak about arrays, structs, and also objects, okay? And all of these falls under data types, okay? The type of data or how data types are defined, okay? So this diagram here shows a sort of a theoretical categorization of data types. What are data types? Okay. So within C++ and any other language, you get data types. You have data types. Okay. But this specific to C++, the data types are categorized in the order of simple, floating, and structured, and also address types. Okay. Your simple data types would include integral, sorry, the three types, there are three types. It's still simple, address, and structured types. Okay? There's another diagram that I'll show you after this. Okay? And then you've got, under simple, you've got your integral types, your enumerators, and floating points. Under addressing, you get a pointer type and reference type. Reference you would relate to when you would pass in parameters by reference. Okay, so that is the reference type. It has to do with addressing. Okay, and then structured data types are includes arrays, structs, unions, and classes. Okay, classes most specifically is the object type, object orientation. Okay. This diagram over here also shows the various data types in C++. Okay, and more specifically, it speaks about the built-in types. Okay. Long under integral. Yeah, no. There is it's actually supposed to be float double and long double. There's two, float double and long double. Yeah. But I'll look it up and make more sense of it specifically. Okay, I see there's two doubles and a long thing. You see, a long is an integral type, okay? But for instance, when you need to store something like a ID number, okay? ID number is how many digits? 30 digits. And you'll find that an integer does not fit that. You need to specify a long, okay? You also have what we call a long, okay? Long, okay? That's also a type that can be declared, okay? So it means it's basically double the size of a long, okay? A short integer, in terms of bytes, storing in bytes, okay? Char, for instance, takes 1 byte, okay? So you can only store one character in a char, where a short is 4 bytes, integer is 8 bytes, and a long would be 16 bytes, okay? And then you just upload 32 bytes, okay? Boolean is also an integral type, okay? It only stores one character, either it's a 1 or 0, okay? Or true or false, okay? Enumerators used in some way also user defined, okay? We'll get to that. So your built-in types include your integral types, your float types, and your void. Okay. Your integral types is your integer, your char, and then also the other lists that you've seen in the previous diagram. Okay. Your floating types is all your float, your decimal numbers, your like your float and your double. Okay. Then you have derived types. Okay, now derived types are basically built-in types, but that they are derived. For instance, in the array, right? It's a derived type because you can declare integer array, okay? Or you can declare a function that returns an integer, okay? Or a pointer that is of an integer type, or a reference also which is a pointer which is either of the other type. So it's basically derived from your built-in types. Okay? Your user-defined data types are those types that is being defined by the user and it makes up the other types, okay? So in a structure, for instance, you have like an integer type or a char type or float type, okay? And we'll show you that. Union, I'll speak about union again. Classes, like I said, is your object types. That is also consists of functions and data types or data declarations and enumeration, okay? We're not going to do enumeration, so I'll not say much about the enumeration, okay? So under your derived types, like I said, that there's your arrays, your functions, your pointers, your reference, and your constants. Okay? So like I said, you can have a function which will return an integer or long or double, whatever, but it also passes other parameters like integers. Okay? So the types refers to a declared type, okay, where you give it a name and you can use that name as a reference to either call the function in the case of a function. So it's a type that you define, declared. Pointers also, we don't, we're not going to do pointers, but we'll speak about the referencing, okay. Pointers you will do in technical programming, okay, when you do that. References and then constants. Constants is also a derived type where you can declare an integer constant. Okay, so in other words, you can declare a constant which will be a max. Okay, constants are basically those types where you declare once and you can't alter it. Okay, so it stays constant throughout the running of your program. Then you usually find that the types are your structures, your classes, your structures, your unions, and your enumerators. Okay? All right. So basically, that is going back to this previous, that is how data types are structured. So we need to look at this portion here, right? Or rather this part here first. Okay? We've done functions last year. Okay? So functions is fine. Then arrays. Okay? So when we speak about arrays, we will also look at structs and then also classes. Okay? That's really what we're going to focus on. Now, in terms of, I've gone through the notes for one-dimensional array just to highlight that the declaration of a one-dimensional array, because it's a derived type, it's a type of built-in data type. Okay? So when you declare the variable, you give it the name, the type, which is the data type, integer, float, long, whatever the type is. You also give it a name. Okay? This name is used to reference that particular memory space or space in memory. Okay? And then max array is the array size. Max array would be a constant that has been declared further up in your program. Okay? And then you initialize, everything to 0, and where you basically the size of the sizes basically to use it when you want to iterate through it. Then you also, in this case, you've got a string, a array of strings, and then that you can, okay, give it initialize to 0, okay? And then char letters is equal to, now, this case here, this is basically an array of no size, okay? Or it could have a size because even a space is a character when it comes to a chart. Space is a character. So you might refer to that as an array of one size. It only has one element. Maybe it's got two. We don't know how big the space is, okay? Or if there's more than one space. But this is basically a chart array. When it comes to strings and charts, okay? A string can also be an array of characters. Okay? So let's say you want to declare a string of 25 characters. You can declare a char and words and then put it 25 words. So what you're saying is that my string will take 25 characters. Okay? Especially when it enter values for names and so on. So a string is also an array of characters. Okay? You can also declare a string like you would normally declare a string, but you can reference it using, for example, let me just do that. So if you declare a string and you call it name, okay, that would be a string declaration there. Right? But you can reference this string um, like that. Okay? You can use a string like that because a string is basically an array of characters. So when you do that, you actually assign the A to the first letter of that string. Okay? Just take note of that. A string can also be referred to as an array of characters. So when you want to define a string, you can define as you can declare a string, but if you want the string to be of a particular length, you declare it as an array of chars or characters. Okay? Does that make sense? Okay. Okay. So that is the one-dimensional array. And I've showed you that a one-dimensional array once it's declared, index is also used as the other word for the index is a subscript, okay, for the array. So that is the one-dimensional array. I showed you how you actually transition or you go through an array, okay, or traverse to the array, okay, using a for loop. Okay? Then we get to a what we call a two-dimensional array. Okay, now you get multiple dimensions of arrays. Okay, you get one dimensional is a single, then you get multiple, which is two, three, four, whatever. Okay, two-dimensional arrays, three-dimensional arrays, four-dimensional arrays. Okay. Examples of a two-dimensional array is your normal grid or normal cells that you see in Excel, because Excel consists of rows and columns. Okay? So let's say you want to store information about the marks of students, it's just figures, okay? Because arrays are a grouping or list of elements where the elements are of the same type, okay? Whether it be a one-dimensional or two-dimensional array. So if you want to store rows and columns, like rows would be, for instance, the number of subjects and the test. Okay. So if there's five subjects and you want to store the test for all five subjects, okay. Subject test one, test two, test three, test four. Okay. That would be a two-dimensional array table. So you will have the marks of the first subject, let's say the average of the first subject for the first test, the average of the second test for that first subject, and the average of the third test for that first subject, and so on. Right? Other examples would be, for instance, let's say, temperature, maximum temperatures for, town, cities for 5 days, okay? So you've got 5 cities and 5 days, okay? So every temperature will be recorded in the cell, okay? That's a two-dimensional array, okay? A three-dimensional array would be basically expand, okay, where, for instance, you would include the provinces, okay? Maximum, so you have the province, and within the province, you have the cities, and then the, the 5 days, okay? There is a three-dimensional array. Okay? So we're not going to speak about three-dimensional arrays, but you can go on to doing that. Right? Um, so when it comes to a two-dimensional array, okay, you still have the data type, you have the name of the array there, and then you have the size of the array specifying firstly the row, that first bracket is the row, in this particular example, it's left empty, okay? And then you've got the columns, okay? Now, this particular row has got 3 rows and 3 columns, okay? So when you initialize the array, okay, you firstly specify the first row, the second row, and the third row in this case, okay? And all of that is surrounded by a curly bracket on either side. Okay? So firstly, the first curly bracket is for the bigger row, and then you've got 1, 2, 3 rows. Okay? And then every row you've got 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? So this particular row would have values stored in, for the first row you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And basically, the row size here would be indicated by the maximum of curly brackets, groups of curly brackets that you got there, and there. Okay? So this is how you would basically display a two-dimensional array. So rows are comma separated. That's the row. So row 1, row 2, row 3. But each row needs, or rather each column is also comma separated within the row. Okay. So 1, 2, 3, 4, 5, 6 would basically be 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9. Okay? And that would be the two-dimensional array arrangement of that. Okay? Alright? So that there is a two-dimensional array. So let me just go back to the. This here is basically a graphical illustration of how it's basically stored in memory. But not necessary, because memory addressing can be, um, I had a picture there about memory addressing, but in memory address would be in some sort of consecutive ways, okay? But I think for now, you need not concern about how it's being stored in memory. This is illustration, or in terms of the coding is what you need to understand, okay? Because it's irrelevant to you, being a programmer, to know what is the memory address, the exact memory address of a particular element in the array. Okay? So that is not so much a concern. Okay? But when you want to get really technical, then you look at it. Yes, sir. Sorry. Yeah, yeah. Yes, yeah. Yeah, that should have been a value, but you see, the row size is indicated by, remember when we said, okay, let's go back here. Remember when we said we can, okay, for one-dimensional array, let me just, okay. We said for a one-dimensional array, let's say array, I'll just use a space there. So you can visualize this to, so that would give it the size, the number of elements in there would give it the size. Okay? Number of elements gives it size, so that's why that is left blank. Okay? So that there tells it that 1, 2, 3, 4, 5, 6. That is the size of the array, right? In terms of the second illustration here, uh, when you define another array here, make that 3, then we say, okay, now we've got that there. Right, so now we say row, row, and row. So that is 3 rows. Okay? And then 3 columns. So here you can put in more. Okay? But now the columns, we've already specified the number of columns with 3. So the columns is 1, 2, 3, 1, 2, 3, 1, 2, 3. But you can add other things to here. You can add more if you're declaring it now, for instance. But we want to actually then put the size in there just to make sure about the size. The reason why I left that out, when it comes to functions, you'll see that that is actually how you parse it. So when you parse it, you don't put the size in there. You only put the size of the column in there when you parse it as parameter. When you play as in the parameter. Yes, you had a question, sorry? Okay. Right? So you can leave the space there, providing that you actually list the number of rows there. And if you don't provide the initialization, then you must give a size on there, okay? So you don't have to, if you don't give a size, you can still give out, you can only specify 2 rows, you can initialize 2 rows only, which means the third row should have zeros in it, okay? That is the two-dimensional array. Right. So this document you have on Blackboard on your Blackboard here. So you can look at that. Okay. So here again is another example: sales, and then that refers to the 3 rows and 4 columns. Okay, 3 rows and 4 columns. Example here, for instance, you've got in your company you have 5 salesperson, 10 salesperson. Okay, you need to determine what the commission was or the sales commission for every quarter. Okay, or for every month. Okay, or whatever the case might be. So you define or you create a type or a variable for sales and then specify the rows for every salesperson and the columns for every quarter. Okay? And in that way you then store the elements in the array, your values in the array. Okay? Initializing a two-dimensional array, that is how you initialize it. Okay? Again, if you don't specify the row or the column, you must still specify the number of elements within the row. So this is simply saying that's 4 rows and three columns. So the first the first size there always refers to the row, and that refers to the column. Okay? So it's basically what we call a table or matrix. Okay? A two-dimensional array is a table or matrix. Okay? So when you refer to an element in the array, you have this here. So guess what this will print, okay? If we're looking at this list over here, A, what values will be printed when you use a CR statement referring 1 and 2? What is the value that gets printed? Okay? First the row, and then the column. So what is, if you're looking at this now, just roughly, what value will be printed? You know, what, there's only one value that will be printed. 25, sure, 21? What is it? 23. So you said 23, that one? So this is the first row, the second column. Yeah, you give me the answer then. Okay, what is it? 25. Okay. So this is the second row. Index. First row's index. So this would be the index 1 would be the second. Okay, so we know now it's somewhere in that second row. Now which one? Which one? 13. Yeah. So it's index 1 refers to the second row, and index 2 refers to the column. So this statement here will print the number 13. Yeah? Okay? And then, of course, here they basically assigning 13 degrees to that which is already 13. Okay? So you can place basically, so that is to print it to assign input the value. So you can do both printing or see out assignment, and then also you do input of the array. So whatever the user enters will go into a particular value there, right? So let's say for instance you've got 3 here and 0 there, right? And you enter a value of 69. Where will 69 go in? Where 11 is. Understand? What did I say? 3 and 0. So column, row 3 is the last row, column 0 is the first column. Okay? Um, so now, when it comes to looping through the array, okay? So remember now, we've got 2 dimensions, okay? We've got a row and we've got a column. You have to control the rows, and you also have to control on which column it is. Right? Let's just go back to this over here. Okay? So when you want to traverse through the rows and the columns, you get, yeah, it depends on whether you first doing the columns and then the rows. Like for instance, you're going um, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so you first go through each row, each column, and then, but you also can move from left to right and top to bottom. Okay, or you can move top to bottom, left to right. So it's just back here. So in terms of looping through an array here, we declare an array called mat of 3 sides and 3 rows and 5 columns. So we also declare a row and column just to as your controlling variables there. Okay. So if you say row is equal to 0 and while row is less than 3, which would be the row there, okay? Because it starts from 0 to 1, okay? And incrementing row, then you iterating the columns, okay? Going through the columns. So you say columns start with 0 and it goes through to 5, okay? So what you will do is on the first row, when the row is 0, you go to each column in that row, on that first row. So the user um, will enter values for column 1, column 2, column 3, column 4, column 5. Then it goes to the next row, column 1, column 2, column 3, column 5. Then the next row, column 1, column 2, column 3, column 5. Okay? Because for every row, you have 5 columns. Once the 5 columns is finished, you go to the top of that loop. Row changes to 1, so which means on the second row, and then it continues on to each row again, each column. Okay? Then you go back there, and so forth. Okay? Now, like I said to you, you can also change the order. Okay? Maybe use the same loop here. What will happen if you change the column to be on that side and the row to be on that side? Or you put in your column there. So basically the same thing will happen if you, let's say if you put column here and the row there, it means that for every row, it will go to each row, because row, a column will now will be the one that changes all the time. Okay? So which means it will first be on the first column, it will go to each row, and then that row, and then that row, and so on. Okay? So we can look at that again in the practical lesson. Okay? That is how you go through the array. Okay? So for arrays, passing arrays by parameters, this is what I'll refer to initially. That when you pass an array as an element in your function, or as an argument, you don't specify the row, you only specify the column size. Like in the case of when you pass a single dimensional array, you don't specify the size of the array, you only pass it like that, okay, for one dimensional array. When it comes to a two-dimensional array, you at least want to know where it ends in terms of the columns, so that you can go to the next row. So that's why we put in 3 here, okay? So 3 signifies the end of the column. Okay? So which means there's only 3 columns. So when you pass the array, you first need to, in your main program or somewhere where you're actually calling the array from, or you're calling the function that includes the array, you have to specify an array, and then you pass that array using only the word array, okay? Now, arrays are always passed by a reference. When you, for instance, when you, this is actually this. Okay, now some of you, one of you, or someone spoke about addresses, okay? When you print out an array like that, what you actually see out there is you're printing the address, the memory location of that where that address is stored. Not necessarily the array, full array, but it prints the starting address of that array. Okay, starting address is also called the base address. So the starting address would be that block there. Right? So when you print out that only prints out the address of that array, the base address. So when you pass an array like that, you actually passing the address to to the calling function. And in that way, we say that arrays are always passed by a reference. They're always passed. You don't have to include what's called the ampersand to say that it is a reference parameter. Or in the case of VB or other languages, putting the word ref there, or buy a ref and buy down. Okay? So arrays are always passed by reference. So when you want to when you want to pass an array and make it read only, you put in the word constant in front of the return type, okay, or the type. You put in the word const. Const means that although the array is passed by reference, it is constant. You can't change the values in the array, okay? Especially when a C output, you want to print it, okay? But if you want to change the values, obviously you don't put in the word constant there. Okay? So here is a complete example of a two-dimensional array, whereby we first display the value, so that is a print, and in your main program, you initialize the array, you give it values there, or declare the array, you give it values, and then you call a print function on that array. Okay? So the reason why we pass 4 and 3 there is because we have parameters for the size, the row size and the column size, and then that is used as your controlling values there. Okay? So that is an example. That is only printing out using the cout statement. Obviously, you can do other things with your array. Okay? Another function array or function for reading, that would be read, input the array, input into the array, and the function to display. Okay? I'm using the set width. Okay, set width. Are you familiar with the set width? And then here is another example to find the sum. Okay, again you can add the sum of the array. Let's basically declare. Yeah, this is adding two arrays. Okay, multiplying two-dimensional arrays. So these are basically just examples. Um, if you've got time, you can actually try to put that in a program and see how it looks. Okay? So that there is one-dimensional arrays and two-dimensional arrays. Okay? One-dimensional arrays and two-dimensional arrays. Okay. Now, data types, okay, or user-defined derived types, basically. Okay? And it falls under in this category where I said here. Okay, so user-defined derived data type. Okay, now we said that it is user-defined because do it. Okay, let me just try to. Like I say, we have you will have one. Here you will have the student number. Here you will have the name. You will have the balance. Okay. So in terms of types, there that will be integer. That will be string, and that can be a float. Okay. Okay. All right. So what you want eventually is to okay. What you want is to have something like that eventually. Okay. Um, so in terms of declaring a type, okay, which will eventually be an array of that elements. Um, okay, let's look at the theory of this. Okay. A structure is a collection of variables which can be same or different types. You can refer to the structure as a single variable and to its parts as members of that variable by using the dot operator. Okay. So the power of structures basically lies in the fact that once defined, the structure name becomes a user-defined type, data type. Okay, and may be used in the same way as other building types that you declare. Okay. So here we've got another example of student. Okay, student number or enrollment number is age, name of the student. Now, like I say here, you can also declare that as being string. Okay, but in this case we have a chart and we're actually giving the size of the string. Okay, here we've got the marks of the student. Okay, and that all ends with a semicolon there, curly bracket and semicolon. When you define that, you define it specifying the type and the name of that type. Okay? Specifying the type and the name of that type. Okay? So, for our purposes here, for instance, you can declare a struct. Okay, we normally start with the curly bracket there, and we say, okay, again, to the number, name, and float balance. Okay, in all of that, okay? So that would be declaring a stuff. Okay? Then we want to specify or make that to be an array of stuff. Okay? Now, here, that's only one single element. Okay? But that element is in reference um, to the dot operator. So when you want to display the enrollment number, you say S2 dot. So the dot there is known as your member access specifier, and that is to specify or actually locate the member of that structure. So here we can then also declare another. So it is sorry struct, and we actually should give the name of the struct. call it student type. So student type, my new data type, and then I want to say students. Students, whatever the size. Okay, so I can declare an array like that, which means that array, although it be a one-dimensional array, it basically looks like a two-dimensional array. Okay, but in this case, the columns are of different types. Okay, and when you refer to it, you still use a for loop, one single for loop, but for every element or every member you reference it using the dot operator. Okay? Like in this case here. All right. The other thing about structures, you can also have arrays within the structure. Okay? You can have another, you can have a array within a struct, or you can make a struct to be an array of elements like I've done over here. Okay? That is a structure. Um, so declaring variables, like I said here, there is a single variable of that array type, but that variable there has got other members. Okay? So when you do assignment, you have to assign each member of it. Okay? This is another alternative way of method of declaring variables of structure type. Okay? So when you do it this way, okay, this here, all of that there in front, the type, okay? The type, and then you specify the variables of that type. Okay? So sometimes you don't want to, sometimes you rather want to keep your structure outside of your main program so that you can redefine or make use it in your function, your main function or other functions. So that's why we put it outside there, okay? And then this is also one way of declaring it. So when you're accessing the data members again, we make use of the dot operator. So which means that refers to the role variable and that age and the name. Okay. So you can assign it individually. You can also initialize it in the same way that you would initialize an array. Okay. But here you actually have to specify the first one, the second one, and the third one being a string. Of course, you have to put in the quotes. And of course the last variable. Okay, nested structs are basically when you have one struct and then you have another struct, but this struct consists of that struct there. So basically it is a struct within a structure, struct within a structure. Okay? In this case, your date, your date of birth is of date type. Okay, date type consists of month, date, and year. Okay, that is a nested stuff there. Okay, so we're not going to speak about type diff. Type diff is something different. So that is all to do with structures. Okay, so what I've explained to you now is these two elements. Okay, well, firstly we spoke about the derived data types, which is arrays, one-dimensional arrays, two-dimensional arrays. You've covered functions on your own. And then we also spoke about the user-defined type, which is in this case is stuff. Okay? Any questions? Yeah? Okay. In this case here, it becomes a global when you play it outside of the main. Okay, it is better to play it outside of the main because it's a new defined type. You want to reuse it somewhere else. Okay, so you want to make it global. So in most cases, it would be global. Okay. I think you can declare it inside a main, but it basically says that that type is specific to that function, which makes it local to the function. Any questions? All right, before you go, I want you to go and read the document, the other document on object-oriented programming. Okay? Right? And just note, just note that the class, the difference between a stock and a class. Previously, or in earlier versions, just listen now, in earlier versions, the stock used to be used for both variables and functions. And you could include a function in the stock and a variable. Okay? Yeah, you can add functions to it. The same way that you declare a variable, you can also add functions into it. Okay? So they are all members of that particular type. Now, a class, the difference between a stock and a class is that a class, a stock is for record purposes only. No functionality is included in a stock. Okay, so your newly defined type only consists of data elements. Whereas within a class, your class can consist of both data types and operations on those data types. Okay? So when we speak about object-oriented language, okay, um, we say that there are two common programming methods: procedural programming and object-oriented programming. Okay, there's a definition of procedural programming. Procedural programming makes use of functions only. Okay, objects makes use of data and operations combined into one unit. Okay? So I want you to read up on that. The next session we will speak about object orientation and how that is being done. Okay?